Oh, this question is super tricky. An equation to represent the value of a fund Q quarters. Remember, a quarter is every 3 months. After a car was bought can be modeled by that function, y equals 18,000 times 0.85 to the Q over 4. So what statements are correct? Here's the thing. When you have, that, I think I say that all the time. Here's the thing. Anyways, Q over 4. Remember, your X portion, or in this case, Q. When you do transformations, remember X is the naughty variable, so it's opposite. So you're not dividing by 4, really, you're multiplying by 4. So Q over 4 is actually a year. So this is saying, the way I can kind of think of it in my mind, oversimplified, 0.85 to the year. So it's actually decreasing 15% per year. And that's this portion right here. Okay. So now let me switch colors. If we wanted to look at quarters, we would actually do 0.85 to the 1/4, which is over here. And then you get 0.960. So it's decreasing 4% per quarter. That's why these two work. You will not have anything that tricky on your test. That's a good one. And let's hope you won't have one that tricky on your regions too. Number 6. This is a good one. This is a really good regions question too. It's got multiple parts. It's looking to see if you can set up an equation. It's looking to see if you can solve an equation. It's a good regions one. But what do I know? An investment of $600 is made at 3.4% yearly interest compounded weekly. So yearly interest compounded weekly means we got 52 compounds. You must know this formula. You have to know all of your formulas. So this is the periodic compounding. So, and remember, move your decimal 2 places to the left. So hopefully this one wasn't terrible to get. One little point on a test, it says write an equation. Make sure you make it an equation, not an expression. How much is the investment worth after 15 years? You plug a 15 in for the T or the X and put that in your calculator. And how many years will it take for the investment to double? So what do we start with? 600. So that would mean our A value is 1200. So that's where this came in right here. So remember your variables in the exponent, you got to get it into log form. So the first thing that was done, that was evaluated just to make it less to write. So this is your base, 1.0007. 52 to the T, 52T is your exponent, and then 1200 is your number. So that 600 right here, you have to get rid of. You got to move it over. So that's why we divide it by 600. Now you have base exponent equals number. So put that into log form right here. And then you can evaluate that log, or you can just go ahead and divide it by 52, and you get 20.4 years. Alrighty, plutonium has a half-life of 87.7 years, in case you wanted to know. A scientist starts with a sample of 600 kilograms of plutonium. So that's your p-value. Write a function to model the amount of plutonium after t years. So here's your half-life, 87.7. Your p is 600. And that's all they give you. So we have, write a function. Oh, here it is. P times 1/2 to the T over H, T over 87.7. And if you notice, that looks like an exponent. Don't write your answer. Oh dear, is it school? Okay, just doctor's office. So, what I was saying is, make my equation. Don't make your exponent look like it's just a fraction that's being multiplied. Make sure it looks like it's an exponent. Okay, so there's our equation. And now part B says, write h of t in the form y equals a times b to the t. So all we're doing is just isolating the variable and the exponent. So here you can see we have 1/2, because t over this thing, 87.7, is the same thing as 1 over 87.7 times t. And then when you put that in your calculator, round it to the nearest thousandth, which is 3 decimal places. That's what you get. And then the last one, you're going to use this by what percent? Hold on. Okay, sorry, dogs got in my son's garbage. Okay, by what percent is plutonium decaying each year? So here's our function. So it's not decaying by 99.2%. Remember, base 0.992 minus 1, and it's 0.008. If it's a negative, wait a second. Oh, it's decaying because that's half. Never mind, I was just having a brain fart. 0.008, so you would say 0.8% decay. What I was thinking is usually if it's a negative, we would say it's decaying, but because it's half-life, it's automatically decaying. My bad. Now I'm going to go stop this video, start a new one, and go to page 3.